assignment before your surprise midterm today, remember? Spring fever. All right, so questions, PA2 or otherwise? All right, anybody play with IntelliJ yet? Sort of?
Found out that if you have like you name like a class or something, I think it's like Alt F6, and you can like rename it everywhere.
Oh, okay.
Which is really cool.
Cool. So yeah, there's this notion of refactoring that IDEs support, and if you want to rename a variable, for example, you refactor it, and it will find, you know, where that variable is referenced. And sometimes you can say, do you want to change this inside comments, for example? So instead of just changing, you know, add to addition, it will make sure that this is actually, you know, the right type of ADD that's being updated. So let's fire up IntelliJ. Progress bar goes all the way to the end of the slash.
No. What'd you do?
It pressed one.
What if that was the nuclear launch button?
The nuclear launch button from Turkey's computer.
I know. You never know.
So I'm going to get rid of my old projects because they were just hello worlds.
I know. You're adding more
No, it's consistent.
All right, so let's make a new project. So again, taking the defaults, and what are we going to call this? We're going to call this Wednesday A.
We're becoming more and more Canadians.
A.
Tuesday. No, it's Shift F6.
Shift F6?
Yeah.
Okay. So let's make a rectangle class. So I'm going to create a new class. I'm going to call it rectangle. It creates the framework for me. I'll make some class variables. I'll make one constructor. So there's my rectangle. Yeah.
So, are packages the same as directories?
More or less. We've got to talk about packages at some point, but basically when you say import java.util.scanner, that's kind of like a package. So you can create a package that contains all of your classes, and it goes into a series of subdirectories corresponding to the name of the package. But then if you want to access it, you can just say import, put in that path with periods in it, and then when you use a class name and it doesn't find the code for that, it will look in that directory. So yeah, effectively it's a folder, but it's a way to have you know, a bunch of different classes with the same name but in different places, and you can refer to them either by saying, you know, subdirectory.rectangle equals new subdirectory.rectangle, or saying import subdirectory.rectangle, and then you can just say rect. And for now, we just take the default class, and it always warns you that that's not a good thing to do, but we can do it anyway. So here's the rectangle class. Let's make another main class. So right click on source, and we'll say new Java class, and we'll call this main. Alright, so R is a new rectangle, it's 3 by 5, and then we're just going to print out R's height. And we can run that. Let's say we're going to run main. It's building, it's compiled, executed, and it tells us R's height is 3. So same kind of thing we can do from the command line, right? It's all tabbed and stuff like that. So here's our main class. Here's our rectangle class. And so it lets you sort of have all your stuff in one area. And it color codes. If you like that, that's good. All right. Anybody still need to sign in? All right. Can you pass that back? And if you come in late and I forget to ask, right, always make sure you sign in by the end of the class. Yeah.
So would you be able to write public default class?
Yeah, it's a good idea to, if you want other code to be able to access the class. There's defaults taken, but it's best to be explicit. And I think this will still work.
Is it what NPA one?
Yeah. But remember, I don't know if that'll work or not. Right, so main has got to be public static void main, because I think the default is protected, which is public within the package and private outside, and it's different from just saying it's public. So this has got to be public static void main. If you leave any of that off, it won't notice it as the main method, and then it doesn't know what to run. All right, so at this point, this is kind of like using Java-C in Java and VI. The main reason we want to use IDEs in this course is because it lets us work with more complex classes. And it will do things like, for example, if we wanted to parse an integer, right? If I type in the uppercase word integer dot, it shows me all the methods that are available from the integer class. And I can scroll through here, and I can see that there's a parse int, which takes a string. There's also a parse int that takes a string and an integer. So this is the one that takes a radix. This is the one that just takes a string to convert. And then if you double click, it'll like fill it in for you. It's watching what you do as you type. So I've got a squiggly line here, and if you just kind of hover over that, it says I don't know about a method called parseInt without any semicolon, without any arguments, right? And it's also saying that there needs to be a semicolon at the end. So I can add a semicolon, but it still wants an argument. And over here I have a little bubble which says, should we split this into a declaration and an assignment? Because I'm declaring I to be an integer and I'm also assigning it this value, and maybe that's not something that you want to do, so it will break it into two statements for you. Is that useful? I don't know, but it's a thing. Alright, so let's try something more interesting. So let's make a new project. And next we're going to call this Wednesday Demo A. I'm going to come down into my source. I'm going to right click, and let's look at this new option. So we can create a new Java class. That's what we've been doing. All the way down here at the bottom, there's two interesting options, GUI form and dialog. I'm going to say let's create a new dialog. So I'm going to click on that. I'm going to pick a dialog name. It's going to say, do I want to generate a main method for this? I'm going to say yes. And generate OK and cancel handlers. I'm just going to leave all of that stuff checked. So new dialog class, so I'll just call this my main. And it makes a whole bunch of code for me. This is classic IDE behavior, right? I didn't type any of this in, but suddenly I've got all this stuff in here. And if I run this, so we'll run my main, what does it do? It pops up a little window. So it's created a window for me, and I can resize it, and it's got a pair of buttons, OK and cancel, and it's got all the usual title bar stuff that you can do, and I can say OK, and my process exits. So this is our first version of a GUI. Right, it's a graphical window, it pops up with some buttons, and doesn't do much, but it's something, right? Okay, now when you start working with GUIs like this, your tabs come in pairs. We're at a tab called mymain.java. That's all of this Java code. And it's declaring some objects. Content pane is what's called a J panel, button OK and cancel are what are called J buttons. There's a main method down here which constructs an object of type myMain, calls a pack method, calls a setVisible method to be true, and then exits. And myMain, the class, does something called setContentPane and setModal and all this other stuff, and add action listener. And for the most part, we're not going to worry about what all of this stuff means.
In the main method, at the bottom it says system.exit0.
Yeah.
Is the 0 exit code?
That's an exit code, so if you did this from Linux, you'd see a 0 if you looked at $?. And let's do something else in here. let's just print a message here saying that our main method is exiting. And so we go ahead and we run this, and oh, it's modal, never mind. Okay, so it exits there. Never mind, we'll come back to that later. Alright, so we have all this code here, and we're not going to worry about it. There's another tab up here, which is my main.form. Click on that one, and you see a picture of your window. Right, so there's some kind of frame here. There's an OK button, there's a cancel button. And if I click on OK, I get a window of properties. It tells me this button is called button OK. And the things that are grayed out are sort of things you don't usually have to mess with. The things that are in a bright color, you might be interested in changing. So for example, the foreground is black. We can change the foreground to something else. We can't change the foreground. So we can change the foreground. I don't know if this will work or not. Change it to red, and we can change the text to say yes. Alright, so you can customize the appearance. We could change the background to make it some hideous yellow. And now when you run, you get a different appearance. So this is heavily customizable. Okay, you can change the shadowing on the buttons. You can change the width of the little box around the outside of it. You could take an image file and use that to fill in the background of the button and make it look like brick or something. There's all sorts of things you can do.
Can you start from where you started, like create a new project or create a new project?
Yeah.
I can't see that anywhere.
Yeah, let's close all this out.
If you give it a maximum dimension, will it not be resizable?
It'll be resizable up to that size.
Okay.
And resizing we'll have to talk about in a bit. Okay, have you gotten this far?
Yes.
Okay, so create new project. Take the defaults, Java project. Take the defaults. Pick a name. Don't put spaces in. So we'll call this demo 2. And you get that far. Expand the name of your project so you get down to a source directory, source folder. Right click on that and then say new dialog.
I don't see that.
Interesting.
I'm very short listed.
Back. Yeah, back to your main. So right click. Interesting.
That I don't have?
I don't think so, but
I never know. Alright,
okay. Yeah, we can look at it later. Alright, so back to our form. These buttons can be moved around somewhat, and the interesting thing about IntelliJ, there's no way that you can design a form where you just take buttons and things and just place them where you want and they stay there. It's not an option. You've got to deal with what's called a window manager. And a window manager is something that basically helps you place your buttons in a way that looks good. So for example, if I run this, yeah, I broke it. if I run this and I change the size of my window, the buttons change size also. The OK button is anchored to the bottom, the cancel button is anchored in the middle, but they stretch out horizontally. And you can control that by placing these things in different spots, and there's these little springs that were in there earlier. And we'll deal with window managers at some other point, because we're not going to get that fancy right now. I just want to sort of explore the space, but basically these horizontal and vertical spacers are like springs, and you can attach different edges of your widgets, your buttons and such, to different edges of your frame or to other widgets, and that controls what happens when the window gets resized. We don't have to get that fancy right now. So let me get rid of these buttons because they're just kind of there. So here's a totally empty frame. Maybe I didn't want to get rid of them because they're still code. Okay. All right, let's make a new button. So I'm going to left click on J button over here, and I'm just going to move my mouse. I'm not click holding, dragging. I'm just moving my mouse, and it's going to let me drop this button either on the left, the middle, or the right. So I'm just going to drop it on the left. There's a new button. And I'm going to change its name to Go. And if I run this, now I got a Go button. Doesn't do anything, right? But I can click it, I can select it, and then hit the space bar to click it. It acts like a regular button. Let's make it do something. So I'm going to right click on here, and I'm going to say create a listener. Okay, so let's talk about listeners. So far, most of the programs that we've written do something usually in a loop, and some part of that loop typically involves waiting for input. So 222, call fgets, wait until the user hits enter, take that input line, parse it, and then do something with a tree, right? PA1 doesn't take any input, it just, had some fractions we constructed, turned into strings, printed out, whatever your main program was. But typically our programs they're always doing something, right? Sometimes that something is in the middle of an input waiting for you to hit enter, and then they go ahead and do things. If you're testing Goldbach's conjecture, you've got a loop, you're generating even numbers, you're writing them as a sum of two primes, and you keep doing this. That's a sort of sequential programming model. Do this, do this, do this, go back up here, do these things again, come over, either over here or there and do stuff, but there's always something your program's doing. Okay, there's a totally different way to write programs, and you get a hint of this in 270 in the interrupt lab. For my class, I give the option of doing it the easy way or the hard way. If you do it the hard way, you get a hint of this, which is something called event-driven programming. And event-driven programming, your main program usually does nothing. It's usually just a loop, which says loop, go to loop. It just sits there. And it waits for things to happen. And when something happens, some other section of code starts to run, responds to whatever happened, and then you go back to your loop that just kind of sits there. And this is how most programming is actually done. This is how operating systems live their life. Your operating system typically isn't doing anything. It's got a section of code that says loop, go to loop. It's just this while one curly bracket, and it's just sitting there, just spinning its wheels. On some systems, there's an actual process called a null process, and that's what the null process does, but it's a genuine process. And if nothing else is happening, the null process is getting the whole CPU. But the operating system was just kind of hanging out. But somewhere in the next 60 seconds, my time will change from 1026 to 1027. And why did that happen? Because some internal counter of the number of seconds went from 59 to 60, and it said, oh, time just increased. Let's go ahead and update that. And if I happen to move my mouse pointer is going to change. And if I happen to click my mouse, a window is going to appear. And if I happen to move my mouse far enough down, a blue box is going to appear, and the word cut's going to change from black to white. Now imagine trying to write the if statements to make all of this stuff happen. If the time number of seconds has just changed to 60, then go ahead and update that to a 7. That was nice timing. If the mouse button is down and you're on this thing, then prop up this dialog. If your arrow just moved to the word cut, redraw the word cut in a different color, right? If the internet connection strength changes, then draw an extra semicircle on top of this symbol, right? All the things that you would have to do, it would be a huge collection of if statements, and you'd never get through that loop because you'd have so many things you need to check. Maybe once every 5 seconds you'd get around to saying, hey, did the mouse move now, right? So that's a really inefficient way to deal with a system where you have lots of things going on. So all this stuff is event driven. When the counter of the internal time bumps up by, usually it's a millisecond, an interrupt occurs. It's a software interrupt. And somewhere there's a piece of code that gets executed in response to that. And that code knows, hey, we just got 1 more millisecond, let's update our internal counter, let's see if we just hit a whole number of seconds. Yep, it's been 1,000 milliseconds, so let's bump up the seconds. Let's see if we just got to 60 seconds. Yes, we did, let's bump up the minutes. And let's update anything that's displaying the current time. And then when the mouse moves, the hardware that's, receiving the wireless signal from here sees a new mouse position, it generates an interrupt. And previously, code set itself up and said, hey, when something happens with the mouse, let me know. I'll be over here on the side, just come over here and tap me on the shoulder if the mouse moves. If the mouse doesn't move, that code has no effect. But as soon as the mouse moves, the operating system says, okay, the mouse is moving, who wants to know? Oh yeah, we need to let them know. Go tap them on the shoulder. So event-driven environments like this are basically set up by doing 2 things. One, software can say, hey, I want to know when something happens. You register a request. You say, I want to listen for events. And then when the event happens, anybody who's been listening for it gets notified. All right, so we're going to use that in here. So if I right-click on this Go button, I can say Create a Listener. And this is going to write some Java code so that when it executes, we'll have code that will be called when something happens to this button. So I'm going to say Create Listener, and there's different kinds of listeners. An action listener for a button means tell me when the button is clicked. A focus listener says, tell me when the button gets focus or loses focus. What's focus? It's the widget that's slightly highlighted. It's the one that if you hit the space bar, it thinks you're pressing that button. Some things can have focus, some things can't. If you have a text area and it has focus, anything you type on the keyboard appears in that text area. If it doesn't have focus, then that's not where the text goes. So you can say, let me know when we gain or lose focus. Let me know when a key is pressed. Let me know when something happens with the mouse. Let me know when something happens with the mouse wheel. So let's just make an action listener. And there's only one type of event that we can ask to be notified of, and that's action performed. Okay, the action you perform on a button is to press it. So we're going to create a listener for action performed. And bingo, we've got a whole bunch of code now. So all of this code, go button dot add action listener, new action listener, public void action performed. And this is kind of cool stuff. So go button is the name of the button, so that's an object. It's an object of type JButton. And go button, we're calling a method called add action listener. Nothing too weird with that. What's the argument to add action listener here? There's a parenthesis after it, so we're passing an argument to it. What's the argument to this?
New action listener.
New action listener. Anything else? How many arguments? Just one. So here is the parenthesis that begins the argument list. Where's the matching closing parenthesis?
Yes.
It's down here. So your argument to this method is all of this. And that looks like the declaration of a method itself. We're creating a new action listener, and then in curly brackets we're putting in some code. All of that, that's the argument to add action listener. So we're calling a method, and what we're passing to it is the code for another method, which is kind of cool. So this is a fancy, tricky kind of thing that you can do in Java. But it saves us from having to write a method and give it a name just so that we can specify that method in this add action listener call. And let's just actually put it inside here. All right, so what do we want to do when the action is performed? Let's just print something. We'll just say the button has been clicked. And let's go ahead and run this. So there's our form. I'll bring it down here. I'll click the go button. Button has been clicked. So we've got a way to tie in what's happening with the mouse and the keyboard and these visual forms with Java code. And that's all you need because you're Java programmers. So you can write code to do whatever you want, and this is how you set it up to run your code when something happens. So let's look at a J button. If this were like a semester length or a year-long course on Java, we would actually dig into all of these details. But we don't have that much time in a 10-week course that's doing object-oriented design, data structures, and Java, and GUIs, and all this other stuff. So we're mostly going to let the GUI do the hard work for us of filling in the specific details of the code. But JButton is just another class. Just like string, it's like math, it's like double, it's like integer, it's like rectangle or fraction, but it's a class that's available to us. And it's part of what's called Swing. Swing is a collection of classes for basically interacting with graphical forms. So a J button is part of an abstract button, which is part of a component, which is part of a container, part of another component, which is an object. Everything's an object. And so a J button has a few ways to construct it. You can construct an empty J button, you can construct a button with some text, you can construct a button with some text and an icon. if you want a picture to appear on it, and so on. And it's got some methods. Not a lot of methods, but it inherits methods from other classes. We have to talk about class extensions still. But it also has all of these methods, such as add-action-listener. And it's got all of these methods, and it's got all of these methods, and those methods, and those methods. So as soon as you make a J button, you've got access to a ton of code. And you can click through and see what any of these things do. So add-action-listener basically adds an action listener to the button. And it takes an argument, which is an action listener, and you can read what that is, and so on and so forth. Alright, and you can bounce back and forth between the form, the visual representation of this, and the actual code. So let's add another listener. Let's create listener. Let's do a mouse motion listener. So this one, when I select, I have a choice. I can select a mouse dragged event or a mouse moved event. Dragging is moving the mouse with the button held, moving is just moving. So let's do a mouse moved. And it created this add mouse motion listener. It's defining a new mouse motion adapter, and it's written some code for me, and I'm going to put in some messages here. I'll say just got a mouse move event, and let's run that. So I'm not clicking, I'm just going to move the mouse over this button, and every time I move it, it tells me I got a mouse move event. And so there's some clicks and there's some more mouse moves.
Is it giving you one per pixel of movement?
Pretty much. Yeah, if you move less than a pixel, it's not going to notice. But if you move more than one pixel before it notices, you'll get one mouse move event for the whole thing. And if something's going on with the CPU at that moment when I start moving, you may not notice the event until, you know, a long time later after I've moved multiple pixels. Okay, well, let's look at this mouse moved method that we just added a line of code to. It's public void. It's called mouse moved. That's how it knows that it should call it when a mouse move event occurs. And it takes an argument, which is a mouse event of type mouse event. So let's see what a mouse event is. I don't know about other people, I never actually read the words in here, but maybe I'll read them now. An event which indicates that a mouse action occurred in a component. Okay, that was good to read.
It's the second time you're reading from this.
Yeah, I know, you get bonus this quarter. Alright, so mouse events, button pressed, released, clicked, mouse motion, moved or dragged. Okay. So what is a mouse event? Well, it has some fields associated with it. Buttons, clicked, dragged, and so on. But it also has some methods. So get button, which tells me if a button has changed state if I pressed or released a button. Get point returns the XY position of the event relative to the source component. Get X, get Y. These return integer coordinates relative to the source component. So we can find out where the mouse is while it's moving. So let's try that. So what's our mouse event called? Mouse event dot. And again, as you're typing, it's reminding you what you can do. And I'm just going to say, let's get X. Did I misspell mouse event? Alright, so when the mouse moves, we're going to call get X and get Y from that mouse event object that came in as an argument, and I'm going to print those out here. And I'm doing Shift F10 to do my builds. Alright, well, let's go ahead and move the mouse. I'll bring it in here on the upper left corner. And so X is small, Y is small. And as I move across, X increases. And as I come down, Y increases. Right? So every time that I change position, I not only get an event, but I can find out exactly where the mouse is. So it's a little weird to do that in the button, but if I had like a big drawing area, I could use this to figure out where my mouse is, and I could do something like, you know, light up a pixel there, or whatever I want to do.
So S and Y can be created the negative number?
These are relative to the component itself, so in this case the smallest they're going to get is 0, 0. Or maybe, yeah, you can get down to 0. So you can make like a cheap sobriety tester here. See if you can make a perfect diagonal line. So this is the kind of thing that you do with these classes. So there's a bigger button. Alright, so what kind of things can we pop here? We've got buttons. We've got panels. A panel is like a place that you're going to drop other things into. So if you want to put down 5 buttons but sort of treat them all as one thing, you can create a panel, put your 5 buttons into that panel, and now if you move the panel, all 5 buttons come along with you. And it's a way to sort of organize the thing that you're designing. We can do radio buttons. So here's a set of radio buttons. So why are these things called radio buttons? Yeah, so old school radios, especially in cars, right, they had these buttons. When you push one button, the last button you push pops out. And it was used for like selector, you know, choosing a station. And only one of them can be pressed at a time. So you click one and the others go off. And if I do this, well, I've got radio buttons, but it's not acting like that. I can select all 3 of these. Right, and that's not a radio button. So you need to associate these with one another. And I don't know if I know how to do that off the top of my head. I'm going to select all 3 of these, and I'm going to say group buttons. And I'm just going to call that button group 1. So now these are all part of a single group. And if I select one, the previous selected one will go away. So those are honest radio buttons now. There's checkboxes. There's labels, which you can use just to, you know, put some piece of information on your display. There's text fields. Text fields are things that you can type into. And so we can run this, and there's a text field, and I can type in it. And a checkbox I can check and uncheck. And I still got my click. Password text field is a text field you type into, but you get a little period instead of the letters, so people can tell how long your password is. And there's lots of things in here, right? Scroll bars and progress bars and all kinds of things. And each of these comes with its own set of actions that are available, different kinds of listeners you can create. So for example, on this text area, let's right click, let's add a listener. Let's add a key listener. And so we can say key typed, key pressed, or key released. Key pressed is when you push it down, key released is when you let it up. Key typed is whatever is considered typing, which is usually when you press, but you don't get another event when you release. So let's just do key typed. And we get a set of code. And this code, key typed, is being called with something called a key event. So let's print a message here. So we'll say key pressed, key event equals, and we'll just print out key event, and we'll hope it has a toString method, which it does. So let's build that. And let's bring this down here, and we'll come into this text area, and I'm going to type the letter A. And it says key pressed, and lots of stuff, but in particular key character equals A. And I'm going to type the letter B, and there's another event, and this time the key character was equal to B. And I'm going to hit the shift button and a B, and there's my uppercase B. And I'm going to hit enter, and well, that kicked me out.
So we could store strings this way.
Yeah, you could take this, and each time that you get a character, you could store it in a string. But this is a, what kind of thing is this? This is a text field. And if you look up what a text field is, AWT is the abstract windowing tool. That's sort of the low-level graphics GUI components. If you look at this, you'll find there's a getText method. And getText tells you the text that's associated with a widget. So instead of building up a string character by character, any time that I get a character event, I could just call the getText method on that text field, and it would show me what the text is in the window right now. And now I don't have to process backspaces or things like that, especially. And let me show you one more thing. Let's add one more listener. We'll do a key listener, and let's do key pressed. Let's just print a message saying key was pressed, and we'll print out the key event. And I'll come over here again. So if I press an A, I get both events. I get a key pressed. No, I said key pressed on both. If I hit the shift key, I get a key pressed event. Right? And the key code is 16, and the key text is shift. And I can use those to tell me that I hit the shift key. If I hit the control button, I'll get a control event. If I hit the alt button, I'll get an alt event. If I hit control alt, I get two events, control and alt. And on some of these you can tell which shift button you pressed. You can differentiate a left and a right. If I hit an arrow button, I get this key text equals up, key code 38, that's an up arrow. So I can tell when you hit the shift button, even if you don't hit like a letter that goes with it, right? This is actually picking up the depression of a key on the keyboard. Whether or not something gets sent in the usual way, it's still an event, and you can pick that up. So if you break this down, you have a tremendous amount of visibility and control over the system. Okay. So we'll keep playing with this. So tomorrow is going to be an open lab. Okay, come in, you can figure out how to get IntelliJ running, or work on PA2 or other stuff. And if you don't want to come in, I'm not taking attendance tomorrow, so I'll see you tomorrow or Friday.